Hey everyone, hopefully you were able to decide if Sasha's and Derek's methods were correct. Both of them actually are, and I was going to take the time today to show you how. Let's say that you have two numbers. Let's do 36 and 48. If you were asked to find the greatest common factor of these numbers, most of you would use the awesome strategy of factor teas, which we've already done so many times. We know that 1 and 36 are factors. We know 2 and 18 are factors. 3 and 12, 4 and 9, 6 and 6. I'm positive most of you could do this in your sleep at the rate we've been working. Let's see what happens with 48. We have 1 and 48. 2 and 24, 3 totally goes in there, 48 divided by 3 is 16, 4 and 12, 5 does not, but I know if 2 and 3 does, and 6 does, so 6 and 8, 7 does not, and 8 does, so I know I found them all. To find the greatest common factor, then we look at the greatest one that they have in common. As I look over here, I'm seeing they both have 6 in common, but that's not the greatest common factor. The one that they share is actually 12. So your GCF is 12. There is nothing wrong with this method. However, today I really want you to try using the prime factorization to help you find the greatest common factor, because when the numbers get bigger and nastier, you're going to see that the prime factorization is actually super helpful. So this might be the point where you want to take notes with me here, but I want you to see how factor trees actually do help you arrive at the greatest common factor of a number. So let's take the same numbers. We have 36 and 48. To find the greatest common factor between the two, I'm going to actually split these guys up into their separate factor trees and find their separate prime factorizations. So if I have 36, which I do right here, I know that I can break 36 into a square of 6 and 6. Those are not prime, so I can keep breaking them up into factor pairs. I know that 2 and 3, which are both prime. And then I have 2 and 3. Which are also prime. I cannot do anything else. So I'm going to write my prime factorization of 2 times 2 times 3 times 3. Now let's do the same thing with 48. I know that with 48 I can break that down into 8 and 6. There's other ways, but that's just how my brain personally works. Then I'm going to break 6 into the factor pair of 2 and 3, which are both prime, and 4 and 2, which 4 is not prime. Oops, 4 is not prime, so I'm going to erase that almost circle. And so then I'm going to keep going like that did not happen. And I know I can break 4 into 2 and 2. That means my prime factorization for 48 is 2 times 2 times 2 times 2 times 3. Now, to find the greatest common factor, you take both of the prime factorizations right here, and you can only take what the two of them share. So as I look, I know that both numbers have 2. 36 has 2 2s, and 48 has 4 2s. But since 36 only has 2 2s, that's all you can take from both of them. So let's take those 2 2s. And now if we look at what's next, they each have a 3. 36 has 2 3s, 48 has 1, so you can only take 1. And if you multiply all of these together, 2 times 2 is 4, 4 times 3 is 12. Look at that. There is your greatest common factor. So to sum it up, to find the greatest common factor using prime factorization, you take your factor trees, you find the prime factorization of each, then you only take what they share, multiply them together to get your greatest common factor.